On to example 2. We still have to rationalize the denominator, but now our fractions are going to have two terms. Okay? Remember, when there's two terms in the denominator, instead of just a single term, you have to multiply by what we call the conjugate. The conjugate of 3 minus root 3 is going to be 3 plus root 3. Change the sign in the middle to get the conjugate. So I have to multiply the bottom by this radical expression to get rid of my root 3, which means on top I have to multiply by the same thing. All right, so let me do a side calculation where I figure out what 3 minus root 3 times 3 plus root 3 is. Okay, I'll work down here. 3 minus root 3 times 3 plus root 3. Well, to calculate radical expressions where you have a plus or minus in the middle, you have to FOIL. So I have to FOIL these two. So there's what I have to multiply. First we do 3 times 3, which is going to give us 9. Okay. Then we do 3 times root 3, which is going to give us plus 3 root 3. Next we have to do the inner terms, which is negative root 3 times 3, so minus 3 root 3. And then finally we do the last terms, which is negative root 3 times root 3. If you multiply underneath the radicals, that's going to give you negative 3 times 3. If we do some simplifications here, well, there's not much we can do with the 9, but this 3 root 3 and this minus 3 root 3 are going to cancel to 0. And then the square root here is going to take the pair of factors of 3 and give you a single factor of 3 back. Which means altogether on the bottom we're just left with 6. So back up in our original problem, when we multiply the top and bottom of the fraction by the conjugate, the denominator, the product in the denominator, is just going to leave us with 6. Right, that's what we calculated down here. Which means in the numerator, we have to actually do some more work. So we distribute the root 27 to both terms, and we get 3 root 27 plus, if you do root 27 times root 3, you would multiply underneath the radical and get 27 times 3, so root 81. If you do your factor tree for root 27, you see that it breaks down into 3 root 3. Okay, so hopefully you guys are good at simplifying radicals by now. So that means you end up with 3 times 3 root 3 after you simplify root 27. And then root 81, that's a perfect square. You know that 81 is 9 times 9. So you have plus 9 over 6. So 9 root 3 plus 9 over 6. When we do our multiplication here. The last step that you should do to go ahead and reduce this fraction as much as possible is distribute this division. Okay, this will end up being 9 root 3 over 6 plus 9 over 6. And then, because we now have a connection by multiplication, we can reduce with this division of 6. 9/6 reduced to 3/2, and this also reduces to 3/2. So in the end, we're just going to be left with 3 root 3 over 2 plus 3 over 2. So let's walk through this again real quick, because this was a fairly complicated problem. All right. To rationalize the denominator when you have two terms, you know you have to multiply by the conjugate. So our first step was to figure out what multiplying by the conjugate did to the denominator. So that's where this 6 came from, because we ended up with 6 as a result here. After that, we had to figure out what happened in the numerator, so we went ahead and distributed out our root 27 in the numerator. After that, we had to simplify all the radicals. Okay, so the root 27 became 3 root 3, and the root 81 became 9. So we had to simplify our two radicals. This was root 27, and this was root 81. Finally, we went ahead and split this division into 2 so we can reduce each fraction individually. Okay, so you want to split this up so you can reduce any of the fractions that have common factors. And that's how we ended up at 3 root 3 over 2 plus 3 halves. So for part B, we have to rationalize the denominator again. And you see we have two terms in the denominator again, which means we're going to have to multiply by the conjugate one more time. The conjugate of root 3 minus root 2 is root 3 plus root 2. So that's what I'm going to multiply the bottom by. Then I have to multiply the top by that same thing to keep the fraction the same. Let me go ahead and do both of these calculations down here so I can save myself room up here. So for the numerator, this time I actually have a sum of radicals to multiply by another sum of radicals, root 5 plus root 6 times root 3 plus root 2. And in that case, the strategy is to FOIL. So what I'm going to get here is root 5 times root 3, which is root 15. Remember, to do root 5 times root 3, you just multiply underneath the radical. That's how we got the root 15. Next, we have to do root 5 times root 2, which is going to give us plus root 10. Then we have to do root 6 times root 3, which is going to give us plus root 18. And then finally we have to do root 6 times root 2, which is going to give us plus root 12. Notice here, some of these radicals simplify. Root 15 doesn't, because that's just 5 times 3, and root 10 doesn't, because that's just 5 times 2. But root 18 will simplify, right, because that's 6 times 3, and then this is 2 times 3. So you have a pair of factors there. Same thing with root 12. This is 4 times 3, 2 times 2, so you have a pair of factors. So let's write the simplified version of the numerator. It'll have a root 15 plus root 10. Instead of root 18, you're going to get a 1, 3 outside and a 2 inside. So plus 3 root 2. And then instead of root 12, you're going to get a 2 outside and a 3 inside. So 2 root 3. So this is what the numerator becomes after we multiply by the conjugate. So let me go ahead and write that in there so we have it complete. Next, we have to calculate what happens in the denominator. So we're going to do a similar calculation underneath here. So I've written out the product that we have to calculate in the denominator. Again, it's a foiling problem. So to expand this out, we're first going to do root 3 times root 3, okay, which is going to give us the square root of 3 times 3. Then we have to do root 3 times root 2, which is going to give us plus root 6. Then we have to do negative root 2 times root 3, which is going to give us minus root 6 because of this negative sign here. And then for the last terms, we do negative root 2 times positive root 2, which is going to give us minus root 2 times 2. Okay. Now if you study what happens here, we have a plus root 6 and a minus root 6, so those are gone. Let's cancel to 0. And then in the two radicals that we have left, in the two square roots, there are pairs of factors. So this square root of 3 times 3 is going to get turned into a single 3. And this square root of 2 times 2 is going to get turned into a single 2. So in the denominator, we just end up with 3 minus 2, which is 1. So in our actual problem where we're rationalizing the denominator, in place of root 3 minus root 2 times root 3 plus root 2, I'm just going to put 1. So when all the dust settles in this problem, all we actually have left is a root 15 plus root 10 plus 3 root 2 plus 2 root 3. That is the simplified form of this fraction after you've rationalized the denominator.